Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one very interesting MCQ regarding proper selection of reagent for this conversion. So I request everyone, please pause this video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now look at which of the below mentioned reagent is best for this conversion. What conversion? This carbonyl group is reduced into this secondary alcohol. Actually, ketone is reduced to secondary alcohol. So overall, if I say this is nothing but hydrogen addition, see one hydrogen added here, another here. Okay, this is a reduction reaction, and look at all four options are actually reducing agent. Now you have to say which reagent is best for this purpose. So that is the trick. By the way, if you look at this compound, it is not a simple carbonyl, simple ketone. It is alpha beta unsaturated ketone. And this alpha beta unsaturated ketone has a very unique property regarding its electrophilic center or electron deficient center. In one case, this carbonyl carbon is electron deficient. How? By this canonical form. So you can expect, okay, this bond can open up like this. This is positive. So you can say, okay sir, this is electrophilic center. Yes, I agree, it is electrophilic center. Not only that, another resonance possible here also. So you can expect, okay, it can push and it can open. So another canonical form also possible. So here O minus, this is positive charge. So beta carbon is also electron deficient. So we need to think which reagent is good for this conversion. I guess we have understand the interest or the important point of this reagent. Now for this purpose, we need to understand the nature of the pi bond and the nature of the reagent. Actually, we are trying to reduce this pi bond selectively. Okay, so you can expect, okay sir, actually if you look at this carbon is more electrophilic. Why? Because it's directly attached to oxygen. Okay, so minus I as well as minus R both operates on this carbonyl carbon. This is more electrophilic. Now if you look at hydrogen palladium carbon, now remember, actually charcoal or carbon is a base, main reagent is hydrogen, palladium is a catalyst. During this reaction, it produces palladium hydride, which is actually the reducing agent, because palladium adsorb hydrogen and form this. If you look at the electronegativity value of both palladium and hydrogen, they are pretty closer. That's why this reagent is called covalent hydride. Now if you look at this bond, it is more polar bond because the electronegative atom directly attached to it. Okay, so palladium hydrogen, if you give, it will preferentially reduce this, preferentially. But what I asked, base reagent for this. So let's check the other option. Now if you look at the second reagent, hydrazine KOH heat. So what is this? This is nothing but Wolff Krishna reduction. By the way, I have already discussed dedicated lecture on it. If you want to learn more, you can visit. Now this Wolff Krishna reduction, what it does, it converts carbonyl to methylene. But what we wanted alcohol. So okay, it doesn't matches with our interest. So this option B is also gone. Now look at sodium borohydride, cerium 3 chloride. What is this reagent? It is actually called the Luce reduction or Luke reduction, whatever you say, that is. So this is a reaction where selectively this hydride attacks this carbon. Now you may think why this is, because this cerium 3 plus coordinates to this carbonyl oxygen. Remember, lanthanides are very strong Lewis acid because of a lanthanide contraction or F electrons, because the F shell has very lower screening capability, so the outermost electrons are strongly attracted by the nucleus, so they are very strong Lewis acid. So the coordinates, and after that this borohydride transfer its hydride selectively at this position, resulting the alcohol, this one. So this is actually, student, the best option for this. Now if you look at the next one, lithium liquid ammonia, by the way, this is nothing but Barge reduction, and Barge reduction on alpha beta unsaturated carbonyl. Okay, so what it does actually in this case, the electron reduces this part, this bond. Carbonyl remain intact. Actually, carbonyl doesn't remain intact, it remains as enolate. Okay, and after workup you can get the carbonyl back via keto-enol tautomerism. So enol will be produced, it will tautomerize to keto. But I have already discussed a dedicated lecture on this also, Barsh reduction on alpha beta unsaturated carbonyl. If you want to learn, you can visit. So from this discussion, one thing is clear that okay sir, which is the best reagent? So best reagent is sodium borohydride. Now there is a confusion about this palladium hydrogen. Since this is present, this Luce reduction reagent is present, so that's why these will be the answer. So now remember, when you solve such kind of MCQ, one part you should remember that which one is most correct. Actually I have asked here based for this conversion. So this is most correct. Now in your mind you may have some doubt, sir, can it be? Is it? May. But remember, some MCQs are there which create confusion, dilemma. That time you need to focus that which are wrong. For example, if you look at this Wolff-Krishna reduction, wrong. Lithium liquid ammonia, these are absolutely wrong. So remove this. This is called process of elimination. Now if you focus A versus C, then you'll clearly understand, okay, this is more accurate. So these will be the right answer. So in this way, sometimes we need to solve the MCQ. I know it's a little different question, so that's why I have selected it. So this is the overall discussion. I believe this video may be useful, and if you really consider the content of my channel is worthy, then please help this channel to grow. And if you have any doubt regarding the logo of my channel, please read this part. Your doubt will be cleared. So see you in my next video. Bye bye.